There we go. All right, we're going to pick up where we left off last time. We were in chapter 2, and we got through the sections up through this section. Up through section 2.3, we were talking mostly about numbers and doing basic math in Python. But we are going to learn about another data type, one that we've used right from the get-go, which is called a string. Now, technically, when we look at any words on a screen or on a piece of paper, every word is built up of letters. And actually, the more appropriate way to think of those letters are as characters of the alphabet, right? And so when we have a collection of characters together, we call that a string of characters. And that's where the word strings come from. So each character is actually seen as its own entity. But at the same time, when you combine them, it becomes a separate thing. So you combine a bunch of characters, they become a word. If you have a collection of words and spaces, you have a sentence. All of those are considered strings. Now, ironically, the string type in this language is not what we call a formal data type. Like, as I told you, like in Java, if we're working with strings, we declare that we're working with strings, and then it allows us to work with strings. Here, we just kind of brute force use them. So like when we did our print statements right from the get-go, we just use the print command, or the function, if you will, and then inside of double quotes, whatever we want to appear on the screen, and that is a string. Anything in between those double quotes is a string, and text that needs to go to the screen. Now, interestingly, anytime we need to put something on the screen, or anytime we are getting any information from the user, it all comes to us as a string, even if it's a number. So that's the irony of that. We're going to see that in just a little bit. All right. We can take any string and we can just directly output it, like in the print statement. And another thing that we can do is we can take strings and we can actually store them as an entity inside of a variable. So here we created a variable called greeting, and greeting holds the string hello. So if I go to print greeting, it's going to output the word hello on the screen. So that's kind of intuitive, I suppose. But if you've never done programming before, it is important to understand that you can store numbers inside of variables, but you can also store strings inside of variables. And the truth is you can actually store more complicated structures than that. But those are the two general data types that we put in there, words and numbers. All right. We also have this concept where we say a string literal denotes a string such as hello, just as a number literal represents a number like the number 2. So when I say, hello is a literal string, it literally is a string. I see it right here on my screen, right? It actually is a string. The variable itself isn't the string, it's just the container to hold it. And this is kind of terminology that you get thrown around. But if I was to go to print out a variable, which may contain a string, I wouldn't call greeting a string literal. The literal would be this. So I'm actually printing hello literally, not a variable version of it. So that's what we mean by that. Now, another thing that you can run into is this thing where, you're going to notice the print command that you can do these combination things. So you can have a string, open and close your quotes, put in a comma, and then output another string. Now notice that the one string has double quotes and the other string has single quotes. Either one can be used. And then, of course, students will have the question, well, why do they allow for both? That doesn't make sense. So pick one or the other and stick with it, right? Well, the reason for that is what if you have a string that you're putting on the screen, and then inside of that string, you want to display quotes? So how do you do that if you're using double quotes to hold your string? You can't display double quotes. So the reason they do that, and this is true of just about every programming language I know, is they allow for both single quotes or double quotes to encapsulate strings, with the thought that there are times when you want to put one of those quotes or single quotes inside of a string itself. to display them or work with them. So that's, I think, important to know. Strings as an entity inside of Python also have what we call string functions that we can attach to them. And one that we use really commonly is this thing called the length function. You can see it's abbreviated so that it says len. And so what that means is I'm going to make my font just a little bit bigger, folks. Maybe that's better. Is if you take your string, whatever that string is, and put it inside of the length function, like we do the print function, it will tell you what the length of that is. So it will go through and count the characters. Now you see here it says the length is 6, but world only has 5 letters, but there's an exclamation as well. So that counts as one of the characters. So really you have 6 characters. So what gets stored in this variable called length is not the string. It will be the length of the string. So if I run this function, the output of that function is an integer or a number. So the length of world is 6, so therefore length is equal to 6. So hopefully that makes sense to you. There are other string functions that are available as well, but we're going to get to those in a little bit. Let's move on to the next concept here, and this is called concatenation and repetition. Now, if you happen to have a couple of different strings, so for example, they use this, a couple of variables here. They set up a variable for first name and last name, and they store in each one of those the appropriate thing. So Harry Morgan, his first name goes in the first name variable, last name goes in the last name variable, but then I want to combine the two together and just put them into a variable called name. So I can do this thing where I'm taking the values of each one of these, and notice how, yeah, I'm adding them together. That doesn't seem like that should happen with words, but when I see this relative to text, where there's a mathematical mark, an addition mark between two pieces of text, that indicates that we're concatenating or joining those strings together. So the word concatenation in programming means the process of joining strings together. Right? So if you think about that, if I take the one string and add the other string, I literally, inside this variable, will have this result. So let's say Harry Morgan. I did combine the two and add them together. Notice what is missing, though. There's no space in between. You know why? Because neither one of these contains, there's no space after Y or no space before M. And so what you might want to do to fix that is actually take the variable version of the first name, add to it a space. Yes, you literally force a space in there, and then add the last name to it. And then when you output name again, now you will get it with the space. But this process is called concatenation, where we join things together by a text. It's a very common thing to do in programming. So you might get like multiple pieces of text information from your user, and then you store that all into one variable and then output that variable. That's not an uncommon thing to do. Now, another thing that we have the capability to do in Python is very unique in this capability, by the way. And I wish I had this tool in other languages. It has the capability of not only using the addition sign to join strings together, but it also has the capability of using the multiplication sign. And when I first saw this, I said, wow, that's really weird. Wait, that's really cool. That was kind of my reaction to it. And so, like, if you're working with console output, so like, the command line programs we've been writing, and you wanted to create like a series of dashes like this, I could literally take that literal string, see how that's applied, and store that in a variable and print it. Okay, and I would get that. But then I would have to type the dashes 50 times to get it. Or what this multiplication symbol allows you to do is take this string, multiply it by a number, and then it just creates this. It just says, oh, you got a dash? You want it 50 times? No problem. Boom, and it does it. And once again, this is very unique to Python. Just another example of that. If we had another string of echo, so echo has, the 4 letters and then the ... and that whole thing is a string in itself. I can store it in a variable called message, and then take that message and multiply it times 5 or print it 5 times, right? Because we're printing, and then echo, 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 echo 5 times. Isn't that cool? I think that's such a simple little technique, for example. And you can try some of those sample exercises there if you have a little bit of time. The other thing that confuses people now is this concept between what you see on the screen and what we're doing numerically in the background. And so you start by looking at this statement. So first we start with a string. So we have the word agent and the space after it. And then given what we just learned, right, we're trying to concatenate a number to it. Well, here's the problem is 1729 as listed here is actually a number. We cannot technically add a number mathematically to a word. Now, if my intent was to say agent space 1729 as a string, I could fix that by actually putting double quotes around the 1729. And then when as soon as I do that, it no longer is being a number, being considered a number, it is being considered characters on the screen that have no numeric value like regular math things do. Now, this is a little bit of a mind bender for people because it doesn't seem like that should even jive. But if I did want to do that, I could take the approach, like I said, literally change this to a string by just putting double quotes around it. That would work. However, often, like if you are working with a number, sometimes it's better to actually use this function we have built into the language called the string function, which will take a number and then convert it to the string. Now, you should say in your brain, right, and this is what my brain does, it's like, what, I can just put double quotes around it and be done. Yes. However, by doing that, all of a sudden you're changing the number. So the one reason, for example, you would use the string function is to leave the original value in place. So, and that's a little hard to wrap your head around at first, but let's just say that this person's ID number is 1729 as a number. And I want to output that to the screen as text. And I would go through a process. So the process would be, the first thing I would do is take that ID, put it into this concatenation statement, convert it to a string, so it does put the quotes around it for us, and then joins the two together. So it would be agent space 1729, all is text. That's what's stored in the name. Okay. And therefore, when I go to print it, it will print the 1729 correctly. If I also want to convert, so if I'm able to convert numbers to a string, can I also convert a string to numbers? And the answer is yes. So if I have the result of something that the user typed at the keyboard, most likely, so you might say like, what's your IQ? Okay, that's my IQ, right? If only. But this is coming in as a string, and the integer function converts that string to the number 1729. And sometimes we do that when we're capturing information mostly from the user. So the user types something in at the keyboard and hits the button, or if you're reading in a file, like an external file that has a number in it, and you need that number to be a string, you might run the integer function to turn it into an integer, or if you need it to be a floating point number, you would indicate float, and then that converts it to a floating point number instead. But it's important to do those conversions whenever you get information from your user. And that takes a little like getting used to, frankly, to think about it. And that's, once in a while, I even forget to do that. Like you grab the stuff and you forget to do a conversion. And then your program will throw errors and you kind of work past it. All right. Now, the other thing that's kind of interesting, somebody might say, well, okay, well, I get that. If that's a string, you can convert it. Well, so can I then take a mathematical equation and that's a string and then convert that to a float? Well, this will not work because, first of all, this is not a recognized mathematical symbol in Python. That is in like, grade school math, the X for multiplication. but that means nothing here. So and that can't work, and it wouldn't generate any value. Even if this was a valid mathematical formula, it still would not evaluate correctly because the mathematical symbol is not something that can be converted and the math executed. It would be converted to a character, but you can't convert a character to a number because it doesn't have any equivalent. So that's a whole separate story. All right. All right, let's move on and go to the next topic here. So that was concatenation and repetition. Now, one thing that I think is interesting about strings, knowing that they really are a collection of what we call characters. And those characters would always be arranged in these little structures. So, and this is a little bit of a thing to wrap your head around, I suppose, if you've never been exposed to it before. But whenever you see a collection of characters, and it doesn't matter what those are, as long as they're a string, they are put together to form a word, but really they are 5 separate entities. So if you look at this word Harry, for example, Harry is a collection of 5 characters. And when we have that collection in a string like this, we can also take each position in the string and give it an index value, starting with the number 0. And then each character can also be identified by that index value. So, for example, if I'm just looking to see if does the last letter of this person's name end with Y, I don't need to check all the characters. That's silly, right? I mean, it's inefficient. I can very intelligently find the last character and then just compare that one. But the way that you do the comparison is by knowing its location. And these index values will always be off by 1 relative to our counting number. So if I were to count the characters, I would say 1, 2, 3, 4, 5, not 0, 1, 2, 3, 4. But the computer always starts counting with 0, not with 1. So the first position will always be 0. And so if I looked at this, and say the length of it is 5, so the last position in the string is indicated with a 4. That's the index value. We'll get a little bit more of that as we go. But if you look at the examples here, I think it really kind of helps. So we take the string Harry, we store it in name. Now, if I want to look at particular letters in Harry's name, so for example, if I want the first letter, I would go to name, and notice the syntax here is square brackets. The square brackets are usually above your semicolon key on your keyboard. Those square brackets with the index value inside say that we're looking at the variable name, but we're looking at position 0. So what's in position 0? An H. This one here says we're looking at the name variable, we're looking at position 4. What's in position 4? The Y. So first will be H, last will be Y. And I think this little graphic shows that pretty well, right? So if you look at this code. And so these are called index values, and then we can find specific spots in that string. Now really the string, is, a collection of characters, and in most languages we call those, gatherings of information, we call those arrays. In Python, we're going to learn that they call these lists, but it's essentially the same structure. So if you have already learned about arrays, the strings are just characters or arrays of characters. If you look at it from the Python perspective, strings are lists of characters, but either way, they all have their own unique identity. When we start to combine that with some of the other functions that are available for strings in this language, we can start to do some kind of interesting and powerful things. So for example, that length function that we just learned about, I can take that name and run the length function, right? And we already have determined there's 5 characters. The length is 5. But you notice they throw in a -1. Now what they do so 1, 2, 3, 4, 5. Subtract 1, what do you end up with? You end up with a 4. So that's how you find the last letter or the last position in that structure. So we take the length of 5 minus 1, which equals 4, and we put it into this variable called POS, or position, seemingly. And then here we can set the last letter, like we did above, to whatever that position ended up being. Now, think about what's different between this and this. This one will work great as long as the name is Harry, right? Which is 5 letters, position 4 being the 5th position. But what if all of a sudden, Harry decides to change his name to, I don't know, Kabir Baja Biamila or whatever. Right? I'm just thinking of like a Packer with a ridiculously long name. Exactly. And if you think about that, so all of a sudden you go from like these 5 characters, I don't know, like 20 or 30 or whatever the guy has gotten his name. And what this little formula would do dynamically is it would read whatever the length is, subtract 1, and then still accurately give you the last position. So if his name was 20 characters long, we would subtract 1 from the length, and the last position would be position 19. So we could extract the last letter by just indicating the position, and it would happen dynamically. So this is a little trick you often see when working with structures like this, where the index value starts at 0, is to take the length and subtract 1 to get the last position. That's very common. So that's why the author shows it here. And the example, so if you like look past like the Harry one, so this person's name here is Rodolfo and Sally, right? So they want to combine these together. So what they're really kind of doing is they're building this with string literals, but they don't want to do the output with the initials to include the whole name. They just want the first position. So this is the first name, this is the second name. They just pull the first position out of each. So first 0, second 0, just pulls those 2 letters and stores them. And then also, you can build it into something else. So this is an example of that program if you want to try it. And in fact, these programs, wherever you see these run buttons, you can just hit the button and it runs a little Python engine in the background and it shows you the output. And then if you came in here, of course, and you started, changing the code or whatever, you can see the fresh output down below. So I always like those. Those are kind of fun. All right, before we move on to the next section, let's take a look at this table here in this section, which talks about some of the what I call basic string operations that you probably will use pretty often. So the one is, how do you store a string? Okay, so here, we have part of the word Python and the other part of it here. So we're storing the first part in a variable, and then we can take that variable, and remember the word is concatenate for this, to join together what we've already stored and the rest of the word and store it back into the variable. Right, so it tells you what it does as an output. Here, we're going to also learn pretty soon that you're going to start creating what we call prompts. So you will start to output stuff to the screen where you're going to say, please enter your name. And you're basically going to be starting to gather stuff. But how you put this together here, it still outputs as one continuous string, even though it's kind of jumbled and split across a few lines here. And that's really the point, is normally, I guess I would just write that out instead of quotes. I don't know why I would split it between lines, but sometimes you get lines that are really long, or sometimes it makes sense to just separate things out so it's easier for you to read as you're coding. But the output of this is still a straight piece of text. Here, we're taking the number 49, converting it to a string, and then joining it to ers, so we have 49ers, right? Here's another example of a little string. So H space and, or ampersand and S, that's the string. And then we get the length of that greetings, which is the 3 letters, obviously, but you also have to count the spaces. Those count in the mix, and that's the point. So if we check the length of reading, it's 5 characters. Spaces count. Uh, they take up storage on a computer, so they count. Here we have Sally as a string that's stored, and we look at this variable in position 1. Position 0 is the first position. Position 1 is the second. So the second position is actually the letter A. So that's why we get an A here. And hopefully that resonates with you. Here's one that gets a little bit more complicated because we're doing one thing inside of another. So if you guys remember this technique where we looked at the length of a string and subtracted 1 to get the last position, well, instead of doing this in 2 separate steps, it is possible, and a lot of programs will do this, is they'll run that function, subtract the 1, and they put that right inside the square brackets. So they don't first store it and then feed in the variable. They just do it brute force right there. So this is saying an elegant way of saying, let's get the last character out of the string all in one fell swoop. And some of that combining of statements, that comes with a little bit of experience, but you'll see that programmers that do it a lot will often go to these shortcut approaches. It's just more efficient. You can do it with 1 line of code instead of 2 or 3. And I think that's really kind of fun to show. Moving on. All right, now we're getting down here to, I think, probably the last major topic for the chapter, which is string methods. And let's talk about first what an object is. And this is kind of on a superficial level. I'm not attempting to teach you object-oriented programming right at this point in time. But it says here, an object is a software entity that represents a value with a certain behavior. And then it says that value can be simple, such as a string, or complex, like a graphical window or a data file. And in programming, you eventually learn how to do all those things, right? And you'll learn much more about this in chapter 9, and yes, you will. We will get to that point in this course. So often when we're working with certain types of objects, so if we're working with strings, some of those strings have attached to them functions, or and another word for a function is a method. So the way that we use like the print command to start out with, we call that a function. But sometimes certain types of structures or objects inside of a program have capabilities relative to what type of structure they are. So for example, if we're doing math, we have methods available to do math related things. So I might have like a method available to do a square root, for example. If I'm working with words, I will have methods available to do things that are, word oriented. So like the first example they give here is they say the name John Smith and they store it, and then they take the name, and notice how they do this. They, instead of putting name inside of the set of parentheses, they go dot upper. So what this indicates to you is this is a method as opposed to a function, meaning it is only available to things of this type, so only to things of type string. I can, and it makes sense, right? If I have characters, I can convert them to uppercase. So this dot upper takes whatever I have here and turns it to uppercase. So dot upper changes John Smith to all uppercase letters. Now, I can also take these more complicated like methods, if you will, and put them inside of a print statement. So I can take John Smith, now mind you, without changing it in memory, right? It's still stored as John Smith with a capital J and a capital S. By using the lower method, it will print out this, all lowercase, without changing what's stored. Okay, so, and that's important, that not changing it is important too. Another method that you'll see is this replace thing. So we know we have John stored in here, but we're going to replace part of that string with something else. So I'm going to find John inside of John Smith and replace it with Jane. And so when I go and output name 2 or look at what's inside of name 2, I now have Jane Smith because I told it to replace the word John in that string with Jane. Isn't that interesting? So that's another method that we can use. Here they have these like these three little basic methods and how they're used. So lower and upper, and then replace the old thing that we're searching for is first, and the thing that we're replacing with is second. So I think that's pretty darn helpful too. So you will have a couple of little exercises where you have to kind of like, you know, fiddle with those things. All right, let's move on to these special topics because I do think they're important to know a little bit about. And the first one talks about this concept of character values. So what this means to us is that each time we type a letter on the keyboard, right? And this is something that you kind of learn in a basic study of computer science. Every time we press a key on the keyboard, what happens is our computer sends out a series of electronic pulses. And to be exact, there's 8 electronic pulses of positive and negative voltages that represent the binary number system. So every key sequence can be represented by a series of 8 binary characters. Over time, they came up with these codes, right, called the ASCII code. And I'm just going to pull up the first one I find here. Sure, let's look at this one. So I want to get a bigger version, but what I'm trying to show you here, and this isn't really a great table because it shows the numeric value of all the keys on the keyboard. So what you're seeing here in column 2 are all the things that you can generate by pressing a key on your keyboard. Sometimes you have to like press like Control Shift Alt whatever and then the key, but these are all built into the standard English keyboard. So you can do most of the Hispanic languages. You can even do Greek and Cyrillic with this. If you notice that there's Greek letters in there. There's math symbols and money symbols, and you even have the little Apple logo. I wonder who developed that one, right? But this is kind of like what we call the ASCII key set. And I'm hoping that somewhere, I guess not on this example, and maybe this one is better. And what I'm really looking for is the binary ASCII table. And I think here we go, this one has it. All right, so, and what I'm trying to show you here is, if I can get that zoom just right, is for every character on the keyboard. So let's say I type the capital letter A, right? My keyboard is putting out an electronic pulse. So it's like zeros would be negative voltages, ones would be positive voltages. So every time I press a key, it's like a series of 8 little pulses. Now think about when you're like speed typing, it's like your fingers are flying. Think of how many pulses you're generating and how many characters are flying around. But that binary value, when converted to a decimal number, equals the number 65. And so what this part of the book that we're reading is telling us is that every character on the keyboard, right, the letter, has what we call an ordinal value or a numeric value that goes with it. An ordinal, basically, all that word means is a way to kind of give it an identifier. You know, it's kind of like a student ID number or something. So the capital letter A has a value of 65. Now, numerically, that is less than B, right? Now think about why this might be helpful. If you want to alphabetize something, how does a computer know to alphabetize something? Did it like memorize the alphabet? No. What it does is it looks at these values, these ordinal values, and orders based upon, you know, which one's smaller, that one goes first. See how it works, right? And then the capital letter A is worth 65, but the lowercase a is 97. And if you were capitalizing something, you know, the capital letter has prominence in terms of alphabetizing something. But I think it's fascinating when you look at this chart that all the keys on the keyboard and then some of the stuff you don't even recognize as keys all have these values. So when you look at what we're doing in the book here and they talk about this ordinal value of H, it says code 97 represents the character of that. But it says the letter H has a code of 72. Is that true? No, according to this chart, it sure does. See that? And then if you look at code 97, what that represents, that is the lowercase a. Now, that becomes important when you start doing things like alphabetizing, for example, or trying to like write a computer program that is trying to differentiate between certain letters and characters. But that numeric value, I'd say, is predominantly used in most Western alphabets as a way to alphabetize and sort data. And with that in mind, that's really important, a little tidbit. But it all stems from this ASCII chart that we see here. And that's something that was developed quite a while ago. And I always marvel at like the people that had the wherewithal to create and imagine these things before we had all the technology, you know, because they had to like sit down and think about it, you know, and what are they thinking about as they're doing it? It always astounds me that their brains are thinking so far into the future, in many cases, decades before the stuff is even useful. And that always blows my mind, you know, the smart men and women that did that work. Next special topic is this thing that we call escape sequences. And this is kind of a bizarre thing that's a commonality in most languages, once again. But sometimes if you're working with like a string, so take a look at the content of the string. And the statement is, you're welcome. So U apostrophe R-E, and then in quotes, we want to say the word welcome, right? So really, this is what we're trying to say right here. But to get that to come across with the double quotes around the word welcome, the only way I can make that double quote appear is to put this backslash in front of it. Because otherwise what would happen is it would see the first double quote, it would print your space, it would see the second double quote, and the string would stop there because it sees the second quote as the end of the statement. And the rest of it, the welcome, whatever, that wouldn't even print. So if you wanted to do that, now you might say, well, why don't we switch the outside ones to single quotes? We just learned that we can mix them, right? So the outside ones could be single quotes, welcome could be in double quotes. Oh, but wait, we got another problem. We got a single quote here. So I would start with the single quote, and then the statement would end here because it sees the second single quote and thinks it's done. And so what they've done with these escape sequences is allow you to force a character in and not have it break the statement. So you do a backslash and then put in your double quote, and it ignores the fact that the statement should end. A backslash puts in the double quote, and then it waits for the next double quote to actually end the statement. So when you hear this terminology escape sequence, it's these special backslashes and the characters that follow that it's allowing to happen. Another one that happens often, like when we are Windows programmers and when we have a statement to access a file on our computer, you can't really type this in because what happens with the backslash, if you want a backslash to appear here, because we use the backslash to do escape sequences, the only way we can make a backslash appear in a string is to take two of them, right? Because that's also our special character for saying that ignore what comes after. So, or print what comes after and ignoring what it normally does. And normally what a backslash does is it designates an escape sequence. So if I want it to render, I have to put two of them in. I hope that makes sense. Now, functionally, the one that I find most useful in terms of escape sequences myself is I really like this new line character. So if I was printing a line and I wanted to like accomplish this output. So when you guys are making your little houses and your names for the assignment, you know, you would do a print, I would just do a print command for each one of this. I'd print 1, print 2, print 3, and be done, right? But you can do that all in one line by actually doing \n, and \n just tells it, all right, print this, go to a new line, print that, go to a new line, print that. And so you can also use that to kind of leverage your output to the screen. And I find that one particularly handy. There are other escape sequences that you can use, and we'll kind of encounter those as we learn about formatting as we go, really kind of on an as needed basis, but here's kind of an introduction to it. So if you get into these weird situations and you're trying to create things, I think the ones that they've showed here are probably the three most useful ones, frankly. All right, let's move on to the next thing here. Now, I always like looking at these little sidebar articles that they throw in here. I think this author does a pretty interesting job of talking about computer history in a relevant way. So like he brings it in when I think it's appropriate. So here we are, we're using an American set of characters on our keyboards. When we look at our keyboards, we call these the QWERTY keyboards, like because the first letters on the keyboard are QWERTY, right? So you guys probably know that already. A number of years ago, I was sitting in class, and it was here at Gateway, and I was teaching, I want to say it was a web programming 1 class, or maybe it was a Java class. And we had some exchange students visiting from Germany. So we have a sister school in Germany where we kind of send people back and forth to. And then I saw one of my students using one of the desktops, and he brought this thing that he had, which is a keyboard overlay, because he learned how to type in German. Now, the Germans use this almost all the same exact alphabet that we do. However, if you looked at a German keyboard, some of the letters are in different spots. And so he's good at typing in German and could type really fast. And then we get to an American keyboard and he's like, oh, shoot, the letter D is, oh, God, you guys put the D here. Why'd you guys put the D here? You know, that kind of thing. And so he would either take the time to switch the keyboard to German, right, and then put his overlay on the keyboard so he knew what he was typing, or he would just have the thing sitting off to the side and he'd go, oh, yeah, it's over here. And so you always have to translate. And we kind of take, these are things we take for granted, right? Because, hey, we're lucky we're in America. We all speak English or some variant of it. And the keyboard is the keyboard and whatever, you know, good luck with the rest of you guys.
It's different in French too, actually.
Yeah, it is too, right? Even though it's the same.
My first language is French, so now I got used to the English, you know, keyboard, but at first it was a trip to like use the English keyboard because I was so used to the ASCII because A and Z's are where, you know, Q and W are ASCII keyboard, so it switches a little bit. Yeah, it took some time sometimes as well. Even now when I write in French, I have to think, when I type in French, I have to think in French, and the letter E, like with the accents and stuff like that.
Sure.
You know, yeah. Sometimes I have to maintain a key, or I have to literally change the keyboard to French from time to time. So
I've from time to time have toyed with, you know, setting up my keyboard to do Greek because I know Greek, you know, but that's a non-Latin alphabet. Some letters are Latin-like, but some are not. I mean, there's some letters in the Greek alphabet that just don't exist in English, you know, and vice versa. So it's really kind of a little bit of a head change. And for as strange as that is, I once, or actually more than on one occasion, have had people who knew Mandarin Chinese in my classes, right? And they raise their hand and I go over and look at their keyboard and I'm like, what what is going on? What is going on here? And what is going on your screen? But you know what the commonality is Windows is still Windows. So even though I couldn't read the screen, I would be able to you know, see what they're doing on the screen and understand, oh, okay, you're in the control panel and you're trying to change your display settings. I recognize that. Yeah, click on that. That's the right one. I don't know what it says, but that's the right one. And so it's amazing how much of that we do. And we do have this very naive assumption here in the United States, or maybe it's a good fortune really, that all this stuff was developed in English, and most of, you know, the educational and business world tend to speak English. The other thing I tell people too with keyboards is, you know, English, you know, being the primary coding language. You know, we have people that are in like China, for example, they have to learn their English characters and language first, and then they learn how to code. So they have this like, extra barrier that you guys don't have. But there's, you know, this naive assumption as well, I think that the United States is the largest English speaking country in the world. Guess what, folks? Not even close. You know, we have um, like, you know, approximately 350 million people in this country. Um, and, you know, we like to think most of us speak English, and that's the case. And maybe there's a few that don't. But the country that with the most English speaking people is actually India. India's got a population of like 1.3 billion people, and their official languages, plural, are English and Hindi. They do both, right? And anybody there that goes to school, especially higher education, I mean, English is the language, and everybody's like, well, why do they speak English in India? Well, the simple answer to that, frankly, is that they were a British colony. So they kind of didn't have a choice, you know. But why do Indian people do a lot of coding? You know, well, because they have that advantage. They already have English under their belt. See the advantage there? And so for them to learn how to do computer programming is great because it's already in their language. The other thing that works well for them too is the fact that you know, they're on the other side of the planet from us. And so when we're sleeping, they're fixing all of our code. And that's very, very much how it works. Now, we do also have this assumption that aside from like different character sets, that we also get languages that don't work the way that like Latin languages do, like Latin-based alphabet languages. So like very specifically, we look at Hebrew and Arabic, right? Which, you know, all of our Latin-based languages, you know, English included, we read from left to right and then top to bottom. You look at Hebrew or Arabic, and it's right to left, or top to bottom. Throw in Chinese, formal character set Chinese, they're right to left. Wait. They start on the right, go down, and then go left. That's formally how Chinese is done. Now that's even more bizarre, right? And so how do we combine all these things together? And what's happened is most of these languages have found compromises. There are people who do write, you know, applications and content that work from the right to left format. A lot of the Oriental countries have adopted their character languages to have character alphabets. Like in the Orient, they have this thing called kanji, for example, heavily used in Japan, for example. And they've also learned to kind of, all right, well, if this doesn't work with coding, well, we'll just switch it to the other way and we'll go left to right too and top to bottom. Who cares? You know, they're a lot more flexible than we are. But at the same time, we should also keep very firmly in our head that at least a quarter of the world's population is Chinese. So that is a pretty huge, and it's kind of interesting to be able to, you know, go to a place like this and look at these character sets and then understand that we have come up with basically character sets to support just about every language. So when we typically work, you know, in this country, we just work with what we call UTF-8, which has the standard ASCII character sets. But it is important to note that you can work with other character sets. And that's really what this is about. That if you wanted to do stuff in other languages, you can actually, you know, if you know the right ordinal values for the characters, you can create just about any character that's available planet-wide with Python. You just need to know the codes.
Mm-hmm.
So that's just something that I like to point out. Not that we really do any of that, but there are people that study this, and a whole huge field of coding right now is taking like existing applications and web content and then converting that to other languages so that you can go to a website, click a different language button, and the whole site just pops in. And I think that's pretty amazing. All right, folks, I'm going to end this video here. I do need to kind of switch gears here a little bit. So let me hit the stop button.